Hi, I am Deshani Geethika from Sysco LABS R&D team. Today I am going to talk about Apache Spark. First of all, I will give you a brief introduction on Apache Spark and then let's see how we can implement a Spark job. Let's get started. What is Apache Spark? Apache Spark is an open source distributed processing system. Basically, Apache Spark is a distributed processing system which can use to process big data. The main advantage or main feature of Spark is Spark utilizes in-memory caching. Let's see about in-memory caching in detail in next slide. Also, Apache has optimized query execution. Therefore, we can do fast analytic queries. Spark supports real-time processing, batch processing, interactive queries, machine learning and graph processing. Spark is originally developed at University of California and later it is donated to Apache Software Foundation. Spark has high-level APIs in Java, Scala, R and Python. So, before Apache Spark came into the picture, HADOOP MAPREDUCE is there for big data processing using distributed computations. So, let's see what are the limitations of HADOOP MAPREDUCE. So, HADOOP MAPREDUCE runs a job as a sequential multi-step process. That means it requires multi-steps to run a job, and in each step MapReduce requires to read data from the disk and perform operations and write data back to the HDFS. Therefore, MapReduce jobs are slower because it requires to access the disk in read and write operations in each step. So, this MapReduce is not suitable for real-time processing. Also, it is not suitable for iterative execution. Some executions like machine learning algorithms, because it requires iterative execution. So, for those kind of scenarios, HADOOP MapReduce is not applicable. Also, it is not suitable for online transaction processing. Let's see what are the advantages of Spark over MapReduce. As I have mentioned, the main advantage of Spark is it has in-memory processing. So, unlike in MapReduce, Spark can run a job in one step. It reads data from disk and loads it into the memory and do operations and write back the results to the disk after all operations. Therefore, it reduces the number of steps in a job, resulting in much faster execution. Also, Spark reuses data across multiple parallel operations. It is done using data frames. Data frames are an abstraction of resilient distributed data sets. Spark is suitable for real-time processing, OLTP, graphs and iterative executions. Let's see what is Apache Spark ecosystem. So, in Apache Spark ecosystem, the main component is Spark Core. That is the foundation for the entire Spark project. So, in Spark's core, there are functionalities for I/O operations and distributed task dispatching and scheduling. So, there are APIs written in R, Python, Scala and Java. So, apart from that, there is a component called MLlib. MLlib is used for machine learning purposes. It uses components for to run machine learning pipelines. Then Spark Streaming is used for real-time analytics. Spark SQL is used for processing of structured data. Then GraphX is used for graph processing. So, as I have mentioned, Spark SQL is used to process structured data. So, it is something like it uses data frame. Data frames is something like used in pandas. In Python, we use pandas data frame. So, Spark SQL uses something similar concept for data frame operations. Now, you have a basic understanding on Apache Spark. Let's see how we can implement a Spark job using Spark SQL. As I have mentioned, there are APIs written in Java, Scala, Python and R. Today, I am using Python to implement my Spark job. So, let's see how we can implement. So, here I have used PySpark library. So, PySpark is basically used to call Spark APIs, and I mentioned that I'm using Spark SQL here. So Spark SQL, if I recall what it is it is used to process structured data. Like, so I will go one by one. So first of all, in Spark SQL, it uses data frames. So data frames, something similar to Python pandas. So first of all, we have to create a data frame. In order to create a data frame, we have to create a Spark session. So Spark session, from this Spark session dot builder method, we can create a Spark session, and since we are running it in local mode, we can mention the master as local, and from this star we can say the number of threads that require to local run. So if I mention a star, that means it will get all the threads to run this job. And I can mention as a name for my Spark shop like this, and by calling getOCreate method, I can create the Spark session. So I will run this shell. So I will run this cell. Then, so now we have created the Spark session, and after creating the Spark session, the application can create a data frame using an existing RDD or Hive tables or some other data formats supported by Spark. So here I am using my Spark session to read a CSV file and load it as a data frame. So here's my CSV file. So I have loaded it to data frame. So this is this acts similarly as in the Python pandas data frame. So if we call df.show method, we can see our data set is read in structured manner, right? So now we have our data set loaded as a data frame, and let's see what are the data frame operations that we can do with Spark SQL. So first of all, we can see our schema. So here are the columns of our data set, and here are the data types. Like all other columns are read as strings, and also we can use df.dtypes method to see the data types. This command is something very similar to the command that we used in pandas. And if we don't like column name, like if we don't like course name, column name of the course name, so we can rename the column name like this using this command df.with_column rename. And we can see that all the columns are read as strings. So if we see the data set, so deaths, so we have deaths, these are in numbers, and we have age adjusted death rate. So this is also a floats, but all are read as strings. So we have to cast these columns into the correct data type. So how we can do it is, we can call df.with_column with our desired column, and we can cast this column to the required type, right? So I cast the deaths into integer type and age adjusted death rate into float type. And if we see the data types now, it is corrected to correct data type. So we can perform some operations, like we can select, here's the year column, and we can use df.select command. And if we want to see only the data related to cancer, so we can filter it like this. We can get the df.causes equals to cancer, and we can run group by operations as well. Like this, we can group by causes, and we can get a count. And here's another example for group by, like if you want to get the sum of deaths for each group and each cause, so you have to group by using year and causes, and then take the sum of deaths like this, right? So this is very easy. So if we convert our data set into a data frame, so we can easily perform these operations to our data frame. Next, we are going to see how we can run SQL queries programmatically. So as the name suggested, Spark SQL. So I am using Spark SQL here. As the name suggested, Spark SQL supports to run SQL queries. So let's see how we can do it. So first of all, we have to create a temporary view using our data frame. So we have to call def.create or replace temp view. So here's the name for my temporary view. So using this one, I can create a temporary view. Then using my Spark session, I'm going to call .sql function, and here I can define my SQL query, right? Select all from dets. Dets is the view that I created, and here's my condition where year equals 2010. So likewise, I can use any SQL query in this function. So here's the same one I have used earlier using basic operations, inbuilt operations. So here I'm going to get the sum of debts in each group, year and causes. So it's very simple like that, right? So here's how we can create a temporary view and run SQL queries. So the problem with temporary views is this view is session scope. That means this temporary view will destroy after the session is destroyed. So if you want to create a view that exists that can be shared among sessions, and that is only destroyed after the SQL program destroyed, so we have to use global temporary views, right? So how we can create a global temporary view is using this command df.create global temp view, right? So here we can create a temporary view named global debts. So if you want to access this global debts, so after we creating this global view, we can run the query as we have done before. Like we have to get the Spark session object and we can run the .sql method. But when we access this temporary view global debts, we have to call global temp.global debts. So this global temp is something that is system preserved database. So we have to call this database and get our temporary view. So likewise, now we can use this temporary view like before. Now I'm moving to some advanced topic like interoperating with RDDs. So Spark SQL supports to convert RDDs into data frames. So Spark SQL use two methods. So the first one is using reflection to infer the schema. So here what Spark SQL does is it can convert a RDD of raw objects into a data frame. So let's see how we can do it. So first I have imported the raw object. So then I create a Spark context using my Spark session. So here I'm going to load my dataset. So my dataset is in text file, unlike before, because these are kind of raw data, comma separated raw data. So then I'm going to map each line I'm going to split each line, and so here is the important part. So here what I'm doing is I'm creating a raw objects. I'm creating raw objects and I'm going to give the parameters as key value pairs. So these keys year, causes, state. So these keys are correspond to the columns of the data set, and these are the values. So I'm going to create the set of rows using my RDD. I'm creating an RDD of set of rows. Then after I have created this RDD, I can call this create data frame method on my Spark session, and from this command I can create the data frame. Right, so this schema dex is the data frame of mine. So it is as same as that we have created earlier. So now we have our data frame and we can do any operations that we have done before. Like, so here I am casting my columns and I am using root by method just like before, right. So that is how it happens. And now also we can create a temporary view and use SQL queries as well. So here's a one way that Spark SQL convert a data set, a RDD, into a data frame. So I'm going to discuss the next method. So here in this previous method, so we have to mention our schema in as key value pairs. In here we have to give these arguments. So if we don't know these ones, if we can't give our if we don't know the schema of our data set ahead, or consider a situation like if we want to give the schema for different people in different schemas, or if we have the schema in string encoded format, so we can't use this method to create the data frame. So what we are going to do in next method is we are going to programmatically specify the schema. Let's see how we can do it. So here I am reading my data set and splitting it with commas, and first what I am going to do is I am going to create an RDD of tuples. So here's the tuple and here are the data points. So here I am not giving key value arguments, I am giving a tuple. So here's a tuple of RDD. Then here's my schema. So this my schema is encoded in strings. So here's the schema string. So using these fields, I am going to create the struct type object. Here's my struct type object. After I have created this struct type object, that means my schema, and I have my RDD of tuples, so I can call this method spark.createDataFrame, and I can create the data frame from this method now. Then we can use any commands like before. We can use SQL commands, and so we have the data frame, so we can do any operations like that. So with that I am concluding my session. I think now you have a basic understanding of how to write a Spark job using Spark SQL. So thanks for watching.